what are we doing? We're using Taylor series, Maclaurin series, really. They're common forms. Oh boy. Yeah, all right, so we're about to do these 4 examples, but first we have to see those common forms. Yeah. All right. Y'all saw me derive all of these. That was the power series. That was like 3 sections ago. Then we took derivatives, we evaluated them at 0, and we found this very convenient form for e to the x. Then we did the same thing for sine. We took derivatives, we evaluated them at 0. We put them in the Maclaurin form or the Taylor form, whatever side you sit on. I think Matt kind of stole it, but whatever. Anyways, you got this, all right? Sine is an even or odd function. Oh, isn't that odd? Cosine is an even or odd function. Oh, isn't that even? Well, that's not even what it means to be even, but let's go ahead and let's work on no. Yes, ease into it. So what do we need with this e in it? Well, now, I'm guessing that you're getting it from the back side. What we want is e to the x is that business. So if I change that, then I didn't change this, or just change that. So I go and I get it. Don't stop. Get it. This is going to be the sum. N equals none to everything. Now, what? That x is now a minus 10x. So wait, all I do is replace. Yes, these are functions. I'm just trying to function. What do I mean? I replace that. I replace everywhere. So then, here we go. On up here. That is, 10 to the n factorial. Now, some people would say that you're done there, but I like to make it a little bit nicer. Yeah, sure. All right. Some of you guys don't even make your bed when company comes over. That's minus 1 to the n, then that's 10 to the n, then that's x to the n, then that's divided by n factorial. And of course, that's going to converge within a certain thing, but the convergence, interval of convergence, that's like, it's the same, well, it's similar. It's in a different video. All right, let's make this short. Now, what goes on here? So I'm looking at that and looks like it is 16x times, whoa, that's the sum, n equals none to everything. It's that same series. That's x to the n divided by n factorial. Oh God. So wait, what? I'm gonna write in some steps that you don't need to see. What is that? This starts at 1, then plus x divided by 1 factorial, then x2 divided by 2 factorial, that's add x3 divided by 3 factorial, and so on. I could go on, but I need room for that one, so then this can go here and here and here and here, and then x gets multiplied by each one of those terms, so it adds an exponent to each one of those terms, so I can go and I can look at that as the sum xn plus 1, because it's adding 1 to each one of those terms. Really, that's it. Alright, so now I see that it is still over n factorial, and of course you're going to find the radius of convergence as important as the t, and important, that one starts at 0. Oh boy, I know, you've been waiting to get involved, now you're here, let's get you here, right there, perfect. Let's go. What are we looking for? We're looking for sine. I see that form over there, so I am going to go and I am going to rewrite that guy. Why does it got to be male? So this is, wait for it, pi x to the, wait for it, sine 2n plus 1. Because that's how you represent an odd function. I was over there like, it's odd, and that's just a way to get you to remember. So rememorize all of these. Oh man, these guys over here, I clipped them from the internet. Now I'm realizing that this should have a -1. That first term is positive, so that's to the n. This should have a -1. That first term is positive, so that should be to the n. Now, all right, I just made those adjustments over here. Be careful what you read on the internet. Yeah, all right, so that was a short form list that I did get from the internet, and there are a lot of those forms, and when I was coming up, I had to memorize a list of like 15, and now they're like 4 because they're like, they can't. Okay, you can get it. Come on, come on. Don't stop. Get it, get it. That -1 should be to the n. N starts at nothing and goes everywhere. Now, down there in that denominator, I have an odd numbered factorial. Yeah, so that's 2n plus 1 factorial. Yeah, all right. So wait, what's the difference now? That x squared is still on the outside because we're trying to make a series for this. Now, some people are like, just leave it like that. And I'm like, come on, lazy? So here we are, we're not lazy. That's n equals 0 to everything. I'm still gonna have my -1 to the n, then I'm gonna have my pi to the 2n plus 1, all right? And then I'm gonna have my x to the 2n plus 1, yeah, because we're using exponent properties. It goes here and it goes there, and then that's all still very over 2n plus 1 factorial. Put it in the parentheses because Baconhead needs his freaking parentheses on things because he's like, I don't know where my freaking thing is. Who's Bacon? Don't worry about it. So what? I still have that x squared out there. So I could expand it out like I did on that last one, but I won't. Why? Because on that last one, you see that it distributes to each term in that sum. So I can go and I have the same base and I'm multiplying. What do I do to their exponents? Adam, you've been hearing me say that for 11 years here? And it still applies to calculus too. I know, I know, I know, I know, I know, I know. So then I go, and that's -1 to the n, pi to the 2n plus 1, x to the 2n plus 1, and then what am I gonna do? I'm gonna add a deuce to that because I have the same base and I'm multiplying. What am I gonna do to their exponents? Add them, and that's how this changes. That's how this is different. That's 2n plus 1 factorial. That should have been the same. The only thing that should have been white was that. So now that's the sum. N equals nothing to everything. That's -1 to the n, pi to the odd number, x to the 2n plus, it's still an odd number, but now it starts at tray and it's all over to, whoa, lazy n, lean back, all right, +1, there you go, it got ends, and of course you're gonna find the interval of convergence. There's a shortcut way and there's a long cut way, but now we're looking for the first 4. It's important in Cali. So what? I'm looking for the first 4 non-zero terms of that business. Now, I'm not sure how far to go into this, but I can replace each one of those terms with that 5x. Yeah, so that's 1 plus, and then it looks like 5x. And then add to it, yeah, 5x, then squared over a deuce plus 5x, tray over a tray, factorial. Yeah, okay, and then that goes on, but I want to also write the sign in there too, and that's odd. So the first term starts with x minus x to the 3rd over 3 factorial plus x to the 5 over 5 factorial plus it goes on. Let me go on. I'm looking for the first 4. So the first 4 terms non-zero, that is. Can we get a constant? Let's see, 1 times, I don't have any constants over there, so we can't get a constant. So my first term is the first power. So 1 times x is Let me just put it in white right there. So x, yeah, because that's there. What's next? X squared. Can I get an x squared by taking a 1 times an x to the third? I can't. I can get an x squared, however, by taking a 5x times an x. So I'm going to add to that 5x squared because that's what I get when I multiply those. Right? So now what? Now I'm looking for x to the third. Can I get an x to the third by multiplying 1 by an x? No. A 1 by an x to the third? Yes. So I can do that. And that 1 times that minus x to the third over 3 factorial, that was from that one. Because I'm looking at my third term. I'm just pointing out that that is a really loud clock. Okay, so now what? I'm still looking for x to the third, so x times x, no, that's x squared. That's how I got that. That's how I got the x to the oh, shoot. I can take that squared term and multiply it by that linear term to get that third term. So I'll do that right here in orange. So it's going to be a 5 squared, which is a minus, because that one's minus, a minus 25 from the 5 squared, and x squared, I'm looking at that. So it is a plus. That's 25x to the third divided by 2 factorial, which is a 2 times 1, it's over a 2. So that was my x to the third term. How many ways can I get x to the fourth? Well, I can get 1 times, that doesn't have any fourths, so I don't need to worry about it. All right, so 1 times x to the fourth, it doesn't get any, okay, 1. That's gonna get you an x to the fourth, and, oh man, looks like that's going to get you an x to the fourth as well. That doesn't have any squares over there, so I'm not even going to worry about that right there. What are we doing? We're going through. We're trying to find the first 4 polynomials of the product of that, just in case we might want to do something with it. So here we go. We're looking for the 4th power. That's a 5 times a, it's not there. Okay, so I'm going to add to it just 1 5, and then that's x to the 4. Sure. Look at that. It's going to be minus. So let's make it minus, and 5. Okay, that's all under, wait, where did your x go? Who cares? Missing 3 factorial is a 6. How else can I get a 4? To the 4th power, that was this one. It was 3rd power times 1st power. 5 to the 3rd power, is that still 125? On a good day. And that's x to the 3rd times x is an x to the 4. Now, then that's all over. This is times that to get to the 4th power. So a 3 factorial, I believe it's 12. 3 times 2, it's not 12. It's also 6. Yes. Was that 4th power 6? That 4th power was also 6. What's the sign on that? That's the 3rd power. The 3rd power. That one is to the 4th. That's the one we're looking at. So that one's a plus. So now all you got to do is clean that up, and I guess I can do it here. So you have an x, and that's a 5x squared, and I didn't do this ahead of time, so it might not be right. So that's a 75 minus 1 is a 74. It's plus, that's an x to the 3rd, and it's all over a 6. What I do, I got a common denominator, and I added. That's a 6, so I needed to multiply by a 3 over 3. 75 minus 1 is 74. Now, here, common denominator, good. Now, looks like 120 over 6, that reduces down to 120 over 6, 12 over 6 is a deuce. So that's 20 x to the 4th, plus, and then some other stuff, but I'll put a big O there for the big O fans. And yeah, first 4, check that. Oh, looks like that could reduce. That's 30... Do it on your own time.